Here we are with the fencing problem. A rancher has 500 feet of fence to make a pen using the wall of his barn as one side of the pen, as shown in the picture here. So if we want to find y in terms of x, we think about the pen being just these three sides. So that 500 feet of fencing that the rancher has is going to be used for the one y and for two x's, making y equal to 500 minus 2x. Nice and easy step, but very important in order to find area in terms of x. So I want a function for area. Area is going to be base times height, so that x times y. Right now it's written in terms of x and y. If I want a function that's only written in terms of x, that means I have to replace the y with what y is, and what we found in part A, 500 minus 2x. Now I know that it's going to be helpful for me to distribute that x, so I'm going to do that real quick right now. 500x minus 2x squared. Those first two parts were really just set up to get to the real crux of the problem, and that is what value of x will maximize the area. If we're going to maximize or minimize something, we need to look at its first derivative. So I'm going to look at the derivative of a, which will be 500 minus 4x. The values that are going to optimize the function are going to be those values where the derivative is equal to 0 or undefined. This function is not ever going to be undefined, but it will equal 0. If 500 is equal to 4x, and I divide both sides by 4, I get that x is equal to 125. So the value of x, this one side right here, that is going to maximize the area, is going to happen when x is 125 feet. Now I could go back and find the area. The maximum area is going to happen at A when x is 125. So we'll just go ahead, take that, and plug it into our area function. 500 times 125 minus 2 times 125 squared. And we get a value of 31,250. This is an area, so our units are going to be square feet.